Okay, so last up, we've got the exponent rule for exponents. What do I mean by that? Let's take a look at our favorite number 3 again, all right? There we go. 3 to the 7th, all raised to the 4th. Okay, let's approach this like we don't know what the exponent rule is yet, because we don't. So we would write this out as 3 to the 7th multiplied by itself 4 times. And then using our multiplication rule, we would just add up our exponents to get 3 to the 28th. Also, it's no coincidence that 28 is 7 times 4, which brings us to our exponent rule of exponents. There we are. So a to the m, quantity raised to the n, is going to equal a to the m times n. Fair enough, but it leaves a lot of room for confusion. Don't get it confused with the multiplication rule. Here we're raising something to a power. We're not multiplying things together. Okay, so let's do just a couple examples of this. There's a couple examples. First, 4 cubed, quantity squared. We multiply the exponents together to get 4 to the 6th. Next, 5 to the negative 2nd, all raised to the 6th power. So negative 2 times 6 is negative 12. So we get 5 to the negative 12th. Now let's try something a little bit trickier, but is worth going over because I see students miss this quite a bit. Let's say we have 2xy squared all raised to the 3rd power. So when you're applying the exponent rule here, the cube goes to each term, not just one. Because remember, if you were to write this out by hand, you would get 3 copies of 2xy squared. So here we get 2 cubed x cubed, and then y squared to the 3rd is y to the 6th. So there you are. So there you have it. Not so bad. Just remember, when you're applying the exponent rule to something that has many different terms, apply the exponent to each term individually. Very important. So the exponent rule of exponents really isn't that bad. Next, let's do a few tough examples to show some applications of the different exponent rules.